In this video, let's take a look at what we call conditional probability. Conditional probability is a probability computed with the knowledge of additional information or additional data. You'll commonly see things like find the probability of A given B in conditional probability examples. So look for that word given, or if you see that word given in some of these problems that you're going through, then identify the problem as being a conditional probability one. Okay, so let's go through a basic example just to kind of give you the idea of what a conditional probability problem looks like. So I said there are 10 marbles in a bag numbered 1 through 10. Now let's imagine that you're blindfolded and that you're going to reach into this bag and grab a single marble. I said, what is the probability of selecting an even marble? Well, if you have the marbles 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10 in this bag, then we can identify the even marbles, 2, 4, 6, 8, and 10. And we have 5 of those out of the 10 marbles. And so you can see that you would have a 1 out of 2, or 0.5, or 50% chance of selecting an even marble. But now what I'm going to do is I'm going to impose a condition. And I'm going to convert this into a conditional probability example. So I said, now let's impose this condition. Let's remove marbles 1 through 5. So instead of looking at the numbers 1 through 10, now we're simply looking at marbles that are numbered 6, 7, 8, 9, and 10. And my question is, what is the probability of selecting an even marble now, given, there's that word given, that marbles greater than 5 are the only ones that remain in the bag? And so now if these are the only numbered marbles that are in the bag, you can see that we have an even marble here, an even marble here, and an even numbered marble here. So 3 of the 5 marbles are labeled with an even number. And 3 out of 5 is equal to 0.6, or 60%. And so we can clearly see that our probabilities are impacted by the conditions that we imposed in the problem. And this is exactly what happens a lot of times in conditional probability examples. Okay, so let's take a look at a more complicated example now. And you'll notice that I do have a formula that's highlighted here on this page, but I am not going to be emphasizing this formula much at all as you're going through these problems. And that is because when it comes to conditional probability, especially in this class, we have the ability to reason through these problems. And so I am going to be strongly suggesting to reason through these problems, and I am going to show you how to reason through these problems. I will also show you in one of these examples right now that the formula definitely does apply, but you'll see that the formula almost overly complicates things. And so we'll try to stick to a reasoning approach with these conditional probability examples as much as possible. Okay, so in this example, what we have is a table detailing some information about crimes. We have crimes against persons, crimes against property, crimes against society. And then we have the motivations for those crimes. And the motivations being racial, religious, and sexual orientation. Okay, our very first question is to find the probability that a crime was motivated by religion, given, there's that word given, that it was a crime against persons. And so the way that I approach this question is as follows. I look at what is immediately after the word given, and I reduce my table to exactly that. So it says, find the probability the crime was motivated by religion, given that it was a crime against persons. So I am only looking at the crimes against persons. And then if I'm only looking at this, what is the probability that a crime was motivated by religion? Well, we can see that that would be 421 out of all of these crimes. And you can see that these are totaled here. And our answer would end up being 421 divided by the total of 4,491. And if we go over here, we see 421 divided by 4,491 is equal to a little over 9%. So if we're rounding to a couple of decimal places, 0.09. Now, if I were to approach this exact same question by using the formula, it would look like this. So what I'm doing is I'm finding the probability that the crime was motivated by religion. So I'm going to write it out like this. Probability that the crime was motivated by religion given, and to emphasize the word given, or to communicate the word given mathematically, we draw this symbol right here. It almost looks like a fraction symbol, but this indicates probability the crime is motivated by religion given that it was a crime against persons. And according to our formula, this is going to equal the probability of both of those events at the same time. The probability that the crime was motivated by religion and a crime against persons, then divided by the probability that it was a crime against persons. So in order to approach this, it's actually helpful to know what the grand total of all of the crimes is. And so if you added the 4,491 crimes against persons to the 3,158 crimes against property and the 12 crimes against society, you would get a grand total of 7,661. Okay, so that's the total of all of the crimes. So when we are addressing the probability that the crime was motivated by religion, given that it's a crime against persons using the formula, and we first have to use the numerator part of this formula where it's saying, let's do the probability that it was motivated by religion and a crime against persons, then you would be looking at this 421 out of the grand total of 7,661. And then you would be dividing by the probability of A. Now, A in this case is the crime against persons, and the probability that it's a crime against persons would be 4,491 divided by the grand total of 7,661. So this numerator reflects the probability of this event and this event occurring at the same time, and then the denominator reflects the probability of this event right here. So as you can see, this would simplify, or you might not be able to see that, but I can tell you that the 7,661 that you have in the numerator and in the denominator would end up canceling each other out, and you'll notice that you end up getting the exact same answer that we got by reasoning. But one of the big things that I want you to see is, isn't it a lot easier to do what we did right here? We simply identified what was after the given as being the focus of our problem, and then we proceeded from there just by reasoning a little bit. And so we end up getting the exact same answer whether we reason or use the formula, but this reasoning strategy is going to be very effective. So let's just use the reasoning strategy in this very next part of the problem. So in this next part, it says, now let's find the probability that a hate crime was against property given that it was motivated by the victim's sexual orientation. So if the crime is motivated by the victim's sexual orientation, then I am going to identify what's after that given, the motivation by victim's sexual orientation. I'm going to identify that as being the focal point in this problem. So I am just looking at what I have circled. I'm just looking at what is after the word given in continuing with the problem. So given that it was motivated by the victim's sexual orientation, what is the probability that the hate crime was against property? Well, that would be 418 out of my total, but this time my total is what I have circled. It's the 1,039 plus 418 plus 3. And so if we just plug this into the calculator real quickly, we'll go 418 divided by parentheses 1,039 plus 418 plus 3. We end up getting an answer of about 29%. So if we're rounding to 2 decimal places, right around 29%. So to summarize, just as you can see once again, reasoning is the most effective approach to these conditional probability examples. So make sure to use this strategy when you see these types of problems in your homework. Thanks for checking this out.